In this video, we're going to be talking about properties of a quadrilateral, pieces or parts of a quadrilateral, and then solving for some unknown measures inside a quadrilateral. So the first thing, let's define a quadrilateral. Quadrilateral is a four-sided shape, any four-sided shape. And the sum of its interior angles are going to add up to 360 degrees. We can kind of see why if we look at this quadrilateral right here. Hopefully you can see that a quadrilateral is created when we take two triangles and stick them together. So if I have a triangle that adds up to 180 degrees and I stick two of them together, I must have a total of 360 degrees inside my quadrilateral. Let's identify parts and name parts of a quadrilateral. So based on this quadrilateral, let's talk about the different pieces we can have. We've talked about diagonals before. Diagonals are corners that are connected. So that segment that connects the two corners there is called a diagonal. We can have two of them inside a quadrilateral. I only drew one. So we can have this segment, segment DA or segment AD. We could switch those letters. But I could have also drawn this diagonal and connected R and T together, and that would be segment RT or TR. And that's another diagonal. So two diagonals in quadrilaterals, and we name them as segments. Opposite angles are angles that are across from each other. So we have two pairs of opposite angles. Angle R and angle T are across from each other. They're opposite angles. And angles D and A are across from each other. They're also opposite angles. Consecutive angles are angles that come next in order. Consecutive means to come next. So I could work two different directions around the shape, and I could start with any angle. I'm just going to choose to start with angle D and work to the right here. So angle D and angle T are next to each other in order around the shape, so they're consecutive angles. I could keep going in this direction and say that angle T and angle A are consecutive. They're right next to each other. Keep working around the shape. Angle A and angle R are next to each other, so they're consecutive angles. And then the last pair, angles R and D, are next to each other, so they're consecutive angles. And we would get the exact same pairs if we had started at D and worked the opposite way around the shape. As long as we have four pairs of consecutive angles, we've named them all. We've seen the word vertex or vertices as its plural form a lot. Vertices are just the corner points of a shape, and they're just points. So we name points using capital letters. We have four corner points here, R, A, T, and D. You can name them in any order as long as you name all four of them and just name them as a point or just use a capital letter. We could have opposite vertices. That would be similar to opposite angles in that they are diagonally across from each other. So point D and point A, or vertex A and vertex D, are opposite from each other. Vertex T and vertex R are also across from each other, so they're also opposite vertices. Consecutive vertices are similar to consecutive angles in that they are corners that come next in order around the shape or are next to each other. So vertex D and vertex T are consecutive vertices. Vertex T and vertex A are consecutive. Vertex A and vertex R are consecutive. And the last pair, vertex R and vertex D, are also consecutive. So four pairs of consecutive vertices. Opposite sides are just sides that are across from each other. The sides we name by using segment symbols. So I have segment RA and DT. So segment RA or AR is across from segment DT or TD. So those are opposite sides. We also have segment DR and segment TA. Here's segment DR and segment TA. They are sides that are across from each other, so they are opposite sides. Consecutive sides are sides that come next in order as we go around the shape, or just sides that are next to each other. So there are 4 pairs. We can start down here with segment DT. That's consecutive with segment TA. Segment TA is consecutive with segment AR. And segment AR is consecutive with RD. We can name those in any order. As long as they are sides that are next to each other, they're consecutive sides. So there are the parts or pieces of a quadrilateral. And half of your skills is being able to name and identify those pieces. The other half of your skills today, being able to use this property, talking about the sum of the interior angles in a quadrilateral. All of the angles in a quadrilateral, all 4 angles are going to add up to 360 degrees. So all we need to do is create equations where we add up all of the measurements, all 4 of the measurements given, set it equal to 360, and solve for a missing piece. So in this first example, we're missing this angle measure up here. So I'm going to add x plus 100 plus 60 plus 95. I know that adds up or equals 360. So let's solve for that missing piece to make it true. Combine your like terms first. Add up all those numbers and we get 255. To solve this equation, we're just going to subtract 255 from both sides. So x is 360 minus 255, so it must measure 105 degrees. In the next example, same exact process, but now we got more expressions. But again, let's set it up. Add up all of the measurements given and set it equal to 360. It's a little bit trickier here, but still try and add up all your like terms. So if we add up our x terms, 5x and 3x give us 8x. Add up all of our number terms, constant terms, negative 8 plus 4 plus 89 plus 51. That should give us 136. To solve this equation, we're going to subtract 136 from both sides first. Now we have 8x equals 224. To solve that, we're going to divide both sides by 8. 224 divided by 8 is 28, and there's our solution. So take a moment here to just compare these two answers. X in this example represented an angle measure, so we're going to say it's degrees. However, in this example, X was just a number, part of our expression. We plug it in to find our angle measurements. So this value of X did not create an angle measure, so we don't put degrees next to it. So there's the types of problems with linear equations. We could also do the same thing with quadratics, though, quadratic expressions, and solve a quadratic equation. So this time we're given some linear expressions and a quadratic to represent our angle measures. We're still going to do the exact same process, add up all of our measurements and set it equal to 360. We're going to combine our like terms. There's only one x squared term, so I'm going to put that at the front. Let's look for our second term. Our middle term in a quadratic is our b term, and that is our x to the first power terms. So we have negative 15x and we have 5x. When we combine those, we get negative 10x. And now we need our constant terms, just our numbers. Combine all of our numbers, 120 plus 120, plus 80 plus 65. That should give us 385. So if we can identify this as a quadratic, to solve a quadratic, we're going to set it equal to 0. So I'm going to move that 360 to the left side of my equation. I'm going to subtract 360 from both sides. When I do that, 385 minus 360 is 25. Now we have our quadratic in standard form set equal to 0, and we could factor to solve it or use quadratic formula to solve. I'm going to practice factoring. Since our quadratic has an a term value of 1, we can just use our x factor technique. Factors of 25 that add up to negative 10, that would be negative 5 and negative 5. So those are the numbers that go into our binomial factored form, and the solution is the opposite of those. We could also set x minus 5 equal to 0 and solve. Either way, we get positive 5 is our solution for x. So there's properties of quadrilaterals and parts of quadrilaterals.